Okay. All right. So we are going to be doing so integration, all right, is the antiderivative, all right? But one of the applications, I mentioned this briefly a couple weeks ago, was that it finds the area under the curve, all right? So basically finds the area of the region under the curve, under the function you have, and above the x-axis, and to the x-axis, I should say, all right? So between the curve and the x-axis, that's what an integral finds, all right? Now, we're not actually going to be finding the exact area today. We're going to do that in the next couple sections after this, but we're going to approximate it. All right, we're going to find an approximation of that area. And we're going to do it three ways: from an equation, from a table, and from a graph. And I'll warn you ahead of time, normally it goes from easiest to hardest, where you start off really easy and then the last one's the hardest, or the most difficult, I should say the hardest. In this case, it's the opposite. All right. The first thing we're going to do is going to be the harder of the three. Not that it's difficult. It's just once you see the other two, you're like, oh, the other two are much easier to do than this one. All right. So start off hard, work yourself down from there. All right. So what's going on here? So if we look at this notation right here, right? So we have the integral, right? We've seen that integral sign before. We see the x squared and we see the dx. So that's nothing new to us. But this 1 and the 4 on the bottom and the top of our integral sign is new. All right. And what this really means, and it says it right after here, is we need to find the area under the curve of y equals x squared from x equals 1 to x equals 4. All right. So a lot of times you'll see, remember how we had intervals from like A to B? Well, that's basically what these numbers are. This number down here is sometimes referred to A, that's your lower bound. B, the top one, is considered your upper bound. It's basically where you're starting and ending, where you're finding the area from. These are x coordinates. So when you see the 1 and 4 there, it means you're doing it from x equals 1 to x equals 4. All right. Now, so if I were to draw this out, all right, y equals x squared is a parabola. But since I only care about it from x equals 1 to 4, I'm only going to draw the right side of the parabola. All right, it looks something like that. So what we are finding is from x equals 1 to x equals 4. So we are finding the area under the curve from 1 to 4. So this green little shaded diagonal region right here, that is what this is referring to, right? The area from under the curve y equals x squared from 1 to 4. All right. So that's what we're going to try in this case, just approximate. If we're going to eventually learn how to find that exact, but for right now, we're going to approximate it, and we're going to do it using a rectangular method called Riemann sums to approximate the area. So we're going to use rectangles, okay, and the area of rectangles. And hopefully you guys remember that the area of a rectangle is either length times width or base times height. All right, base times height or length times width. Doesn't really make a difference. You know, if I got a rectangle, I multiply this side times that side. All right, we all know that. Okay. So what we're going to start off with is just using one rectangle. This, I warn you ahead of time, will not be a great approximation, but we're just going to start off with one. All right, a couple things to recognize with notation wise. You see where it says n equals 1? N stands for the number of rectangles. So when it says let's use one rectangle first, it says n equals 1. So if I said n equals 4, that means we're going to use 4 rectangles. If I said n equals 8, we're going to use 8 rectangles. Next thing, delta x. Delta x is the width of the rectangle or the base. Sometimes I like to refer to it as the base. All right. So in this particular problem, delta x is going to be 3 because the base, the length, the width of it's a change. Delta x stands for the change in x. All right. So it goes from 1 to 4. That's going to end up being 3. Okay. All right. Now, there's two things here. We see left sum versus right sum. All right. And it's real simple to figure this out. Left sum means that we are going to use the left side as our height. If we do a right sum, shockingly, we're going to use the right side as our height. The right side of the rectangle, and of the region. You'll see what I mean in a second. Use the right side as our height. Okay. All right. So area is going to be base times height or length times width. All right. Basically, it's going to be the height, which is either going to be right now. So if we think of base times height, our base is going to be our delta x. Our height is then going to be either our left side or the right side. So I have the base, which is going to be our delta x, which is 3, right? From 1 to 4 is 3. Times the height. Okay, so we are doing it from 1 to 4, right? So it's either this side I'm going to use, that little pink side, or the right side is the orange side. So you see how there's two heights there? It's either the left side or the right side. So since we're doing a left sum, I'm going to do the pink side because that's the left. So how do I figure out this height? All right, and this is where the three ways we're going to do it, from an equation, from a table, and a graph, are going to differ to how we find these heights. In order to figure out how high that is, I need to know what that point is, right? I need to know that y value. If I know that y value, then obviously I know how, if that was at 2, then I would know that this height is 2. If it was at 8, that height be 8. Well, how do I figure that out? By plugging that 1 into x. So whatever 1 squared is, which we know is 1. So 3 times 1 equals 3. And that is our area. So what we just found was the area of this pink rectangle. Now, if you compare the area of that to the green, it's obviously an under approximation. It's not a great approximation. You can see that there's still a lot of stuff under there that's not taken into account, right? So the left sum of this problem with one rectangle would be 3. The area of it is 3 because we use the left side as my height. Delta x, the base was 3. There's only one rectangle here we're going to worry about, so it's just 3. All right. Now, let's do the right sum, then I'll ask if there's any questions. So, same thing, base times height. The base is still going to be 3, right? We're still using this delta x is 3. That's the width. The difference is now we're going to use the height is the right side. So we're going to go to 4 because that's the right. 4 is on the right, 1 was on the left. So now we're finding the area of this orange rectangle, which you can see is much bigger than that green, which is going to be an over approximation. All right. So now how do I figure out this height right here, right? Well, I need to figure out what that y coordinate is of this point up here. Well, how do I do that? I take 4 and plug it in for x. So it's going to be 4 squared, which is 16. 3 times 16 is 48. So with a right sum, with one rectangle, you get 48. The left sum, you get 3. Obviously, they're way off, right? One's real small, one's real big, right? But any questions where I got any of those numbers to start right now and understanding the difference between left sum and right sum? Okay. Now, obviously, this is a awful approximation. All right. It says it right here, not a great approximation. What will be a better approximation is if we use more rectangles. All right. So we're going to use, in this problem, we're now going to do 4. All right. So n equals 4. We're now going to do 4. So let's just draw. We're going to use the same exact, it's the same picture, same situation. So it's y equals x squared. We're going to do it from 1 to 4. All right, it's going to be the same thing. All right, but what we're going to do is we are going to split up this region into 4 rectangles. So now we're breaking it up this way. All right, and you can see I have 1, 2, 3, 4 little regions that we're going to deal with, and we're going to turn these into rectangles. Okay. Now the question is that we need to figure out first, and this is always the most important thing, is what's this base right here going to be? It's going to be the same for all of them, and that's what delta x is. We need to solve and find delta x. All right, so the little formula that we are going to use is b minus a over n. B is where we stop. A is where we start. Remember, if we have the integral, remember we had 1 here and 4 there. And I told you the number on the bottom was your A, the number on the top was your B. So that means the B is 4, the A is 1, the N is 4. So 4 minus 1 is 3, and 4 is on the bottom. So our delta x is going to be 3/4. All right. So that means that this base here, that distance there, that distance there, that distance there is all going to be 3/4. All right. So the next thing, once you find your delta x, is you need to know these x coordinates, because those x coordinates we are going to plug in for x to find our heights. So what you're going to do is you're just going to do 1 plus 3/4, whatever you get, you're going to add 3/4 and keep adding 3/4 until you get to 4. So 1 plus 3/4 is 1 3/4, which is otherwise known as 7/4. 7/4 plus 3/4 is 10/4. Now you could reduce that to 5/2, but you can just leave it as 10/4. 10/4 plus 3/4 is 13/4. And then 13, if you did 13 plus 3, 13/4 plus 3/4, you get 16/4, which is what? 4. All right. So the first thing you want to do, to recap here, find the delta x, and then keep adding to find your x's. And we've now split it up into 4 regions. All right. Questions up to that point. Once you get this, the rest is pretty easy. Okay. All right. So what I have to do now is what I'm going to do is I want the right sum. All right. I'm going to do the right sum, which means we're going to use the right side as my height. So if I look at rectangle 1, I have my left side that has an x coordinate of 1, the right side, which has an x coordinate of 7/4. So since I'm going to use the right sum, I want the right side as my height. It's going to be that rectangle. When I get to 2, all right, my height, my left side 7/4, my right side is 10/4. I'm going to use my right side. And all of them, I use the right side as my height. All right. So what I'm going to do is add up the area of all 4 of those areas. Hold on 1 second. All right. Sorry, I said to close the door there for a second. All right. So instead of just, so I'm going to do area of rectangle 1 plus 2 plus 3 plus 4. To make things easier, what do all of those rectangles have in common? They all have the same base. So instead of doing 3/4 times the height of this, 3/4 plus all that, what we can do, and we can always just put whatever delta x is on the outside, like pull it out. So in this case, it's 3/4. All right. We will always put delta x on the outside. So it's going to be 3/4. All right. Hold on. I don't like the way that looks. Back. Erase. All right. So 3/4 is go on the outside. All right. And what that is this is delta x. All right. That's always going to go on the outside. Then what we're going to do is we have 4, 1, 2, 3, 4 heights that we need to have, right? Because all of these bases are the same 3/4. Now we got to do the heights. Now remember, we did the right side. Well, I need this point, this point, this point, and that point. And we do that by taking all of the x coordinates and plugging into x. Remember, it was x squared. So I'm going to plug in 7/4, whatever that is squared. I'm going to do 10/4 squared. I'm going to do 13/4 squared, and I'm going to do 4 squared. All right. The reason I did 7/4 because in rectangle 1, the right side was 7/4. Rectangle 2, it was 10/4 the right side. 3, it was 13/4. Rectangle 4, it was 4. And what you would do is just plug that in to your calculator and get an answer. And whatever it says would be your area. And in this case, it's 26.9. Right? And that was the answer. Right? 0.906, but that's good enough. All right. Now, if it was the left sum, I know it doesn't say, the only difference that you would have is the left side would be, right? It would be like, I'm just drawing dotted lines here. See these little, like that's the area we would find. So everything would be the same, except for rectangle 1, you would plug in 1 squared. Then it would be 7/4 squared for rectangle 2, 10/4 squared, 13/4 squared. You wouldn't use 4. All right. So when it was right sum, you didn't use 1. When it was the left sum, you wouldn't use 4. All right. All right. Any questions on that one? Now, the reason this is the hardest is because you have to find these numbers yourselves, and then to find these heights, right? Because what these are the heights of the rectangles in here. All right. Those are the heights. To find the actual numbers, you have to plug in to get that, but you can use your calculator. And you'll see why it's going to be much easier in a second here. But any questions on the equation part? Okay. All right, so that was an equation. Next is a table. Right, so what we are given here is some function where we have, these are your x coordinates, right? 2, 4, 6, 8, 10. And these are f of x, these are the y coordinates. So this is saying when you plug in 2, you get 50. You plug in 4, you get 60, and so on and so forth. Well, you know what these numbers end up being? These are the heights. So we're not going to have to plug in numbers. They're already telling us what the heights are, right? So these things right here are the heights: 50, 60, 70, 90, 115, all right? Which is going to make, like I said, life a lot easier. Okay, so we are starting this little, so basically what this is like we have the integral of some function, and it starts at 2 and it ends in 10, right? Starting at 2 and ends in 10. We want to do a left sum where n is equal to 2, all right? So the first thing you must do is find delta x. Remember, delta x, I'm going to write the formula again up here, is b minus a over n. You must know delta x. So delta x is b, which is 10, minus a, which is 2, right? Where you end minus where you start, divided by how many rectangles you want. In this case, I want 2 rectangles. So 10 minus 2 is 8. 8 over 2 is 4. So delta x is 4. All right, so that means that when we do our area, 4 goes on the outside, right? Delta x always goes on the outside. Now, there's 2 rectangles. So I'm starting at 2. If my width, my base is 4, what's 2 plus 4? Well, 2 plus 4 is 6. So my first rectangle starts at x equals 2, ends at x equals 6. My next one goes from 6 to 10, because 6 plus 4. So there's rectangle 1, there's rectangle 2. All right. So since it's a left sum, that means my first rectangle starts at 2 and ends at 6. Well, what's the left side? The left side is this one. Well, nice and easy. What's the height? It's just 50. See, you don't have to plug anything in. It just tells you what it is. That's why this is so much easier. Then the second rectangle goes from 6 to 10. Well, left sum, go on the left side. What's the height on the left? It is 70. 50 plus 70 is 120. 120 times 4 is 480. And there is your answer. 480. All right, any questions on that one? All right, now with B, we're given delta x. Delta x is 2. So now, if we start at 2, we're going to have a rectangle from 2 to 4, 4 to 6, 6 to 8, 8 to 10. So we have 1, 2, 3, 4 rectangles in this problem. All right, I know the width is 2, right? There's 1, 2, 3, 4. So the first rectangle starts at 2, ends at 4, then 4 to 6, 6 to 8, 8 to 10, and so on and so forth. Right? So to figure out the area, you put delta x on the outside, which is 2. Then there's going to be 4 heights that I need. It's the right side. So starting here, I'm going to use all these numbers except which one? I'm not going to use 50 because the first rectangle, the right side is 60. The second rectangle that goes 4 to 6, the right side is 70. The third one that goes from 6 to 8, the right side is 90. And the last one is 115. So you just add 60 plus 70 plus 90 plus 115, and then multiply that by 2, gives you an answer of 670. All right. So is everyone all right with right sum, left sum? I'm going to throw a little curveball at you, but it's not really that hard. So midpoint sum. What's midpoint sum? Well, before we get to midpoint sum, we need our delta x. This saves time. N equals 2. We just did that. N equals 2. Delta x is 4. All right. So I have 4. I have 2 rectangles. So if left sum, we use the left side as our height. The right sum, we use the right side as our height. Midpoint sum, we're going to use, shockingly, the middle, the midpoint. So if I go to n equals 2 and delta x is 4, so that's our first example where we went from 2 to 6 and from 6 to 10. All right. So 2 is the left side, 6 is the right side. So what's going to be the middle? It's going to be 4. What's the height at 4? It's 60. All right. From 6 to 10, right? That was the second one. 6 is the left side, 10 is the right side. 8 would then be the midpoint, right? 8 is in the middle of 6 and 10. So I use 90. And then do 60 plus 90 times 4, which is 600. 600. So that's how, so obviously it would have to be something, I couldn't have done the midpoint sum for like B, where delta x was 2, because I don't know what the height is at 3 between 2 and 4. All right. It would obviously have to be something where you know clearly what the midpoint is. Okay. All right. So hopefully you can see why it's a little bit, this one's easier because you don't have to do any calculations. It's given to you. All right. It's given to you. All right. Last one. Last type is a graph. Now, the only difference between the table and a graph is the table tells you numerically the points, 250, 460, and all that, right? The graph, it gives you the points, but it doesn't, you just have to figure them out by knowing how to do an X, Y coordinate, but it's the same thing. All right. All right. This is like when X is -8, Y is 0, right? This is -4, 8, 0, 4, so on and so forth. All right. So we are going to figure out a right sum where n is equal to 6. So I need my delta x. Now, so that's b minus a over n. B is where I stop, which is 16, where it ends. A is where it starts, which is -8. And n is 6, which I'm given. So double negative there. So that's 24 over 6, which is 4. So delta x is equal to 4 in this case, right? So we go from there to there to there to there to there to there. And there's our 1, 2, 3, 4, 5, 6. First rectangle starts at -8, finishes at -4, -4 to 0, 0 to 4, so on and so forth. Right? So to get my right sum, what always goes on the outside? Delta x. And there's going to be 6 heights. So it's the y coordinate. So I'm doing a right sum. So from -8 to -4, what's on the -8 is the left, -4 is the right. So I find the y coordinate there, which is this point. That's 8. Then from -4 to 0, what's that? The right side is this one here, which is 4. Then my next one, the right side is this, which is -4. Then the next one is -12. Next one, the right side, this one is 0. And finally, you have 12. And if you notice, you should have 6 numbers in there. 1, 2, 3, 4, 5, 6. All right. And if you add all these up, these 12s cancel, these 4s cancel, just 4 times 8, which is 32. All right. So 32 is the correct answer. Any questions on that one? All right. Last one that we're going to do today. Midpoint sum, delta x is 8, which means we're going to have from -8 to 0. That's the first rectangle because delta x is 8. That's how long the base is. Then we're going to go from 0 to 8, and then 8 to 16. All right. So based off of that, and it's the midpoint sum, see if you can set up what the area equation should look like and then what it actually equals. Go ahead and try that. Give you a minute. All right, so remember, delta x always goes on the outside, so that's going to be 8. Right? The reason I know there's 3 things here because there's 3 rectangles, midpoint. So my first rectangle is going from -8 to 0. So the middle between -8 and 0 obviously is -4. So I want that height right there. So I take that y coordinate, and it was 8. For my second one, goes from 0 to 8. The middle is 4. So I need to know that y coordinate down here, which is -4. And then finally, it goes from 8 to 16. So the middle is 12, which obviously that y coordinate is 0. So 8 plus -4 is 4. 8 times 4 is 32. You end up getting the same answer. That is purely a coincidence. So the answer is 32. All right. So we have 3 different types: equation, a table, and a graph. All right. Now, the only thing that changes is how you get the heights on the inside. Delta x will always go on the outside. If you have a graph, the heights are all the y coordinates that you actually just have to look at the points to find the y coordinates. In a table, those heights are here at f of x. Those are all your heights. And then with an equation, all right, that's my stuff got deleted already. You have to go and plug them back in to your x. All right, you take your x coordinates and plug it back in. That's why the equation is a little bit of a pain. All right, but I think after seeing the other two, you probably even understand the equation one a little bit more, hopefully. All right, so what we'll do tomorrow is I have a bunch of examples of different types of these. So we'll do a couple equation, a couple table, a couple graphs, and we'll work on those together in class. All right. Normally those would be for homework, but I'm not going to give you homework. I'm just going to work on that with you guys together tomorrow in class. All right. Any questions? All right. Well, I hope you guys enjoy the rest of your day. If you do have anything, questions come up, make sure you ask. Also, make sure you make up any missing work. All right, over the course of the next week or so. All right. I hope you guys have a good day, and I'll talk to you tomorrow.